KEKO Equipment is a world-leading manufacturer of machines for production multi-layer ceramic structures and circuits. LTCC material is one of the developed materials at our company. This material has been extensively used in the industry for the last 20-30 years, and especially for making circuits, electronic circuits, especially for high-frequency applications. This material enables co-firing, so making all together the ceramics and the metallization in the same process. It also enables to integrate the cavities inside the structure, which may be used for ceramic microfluidic systems as well as pressure sensors. The production of the pressure sensors, which are with working temperature from -20 till 400 degrees C, was realized with the help of the partners.
The challenges that we faced in the development of ceramic pressure sensors for high temperatures involved the design of the sensing principle, the choice of the materials, the technology, the fabrication conditions, and finally testing of materials that would survive temperatures up to 500 degrees C.
An innovative high-temperature ceramic pressure sensor based on LTCC technology for temperatures up to 250 degrees was developed within the project, even though the initial plan was to develop one version for up to 180 degrees and a second version for up to 400 degrees. Although the solution was demonstrated for a pressure up to 2.5 bar, the technology can easily be adapted to certain pressure ranges. Therefore, the partners KEKO and GSI developed the ceramic pressure sensor element and the required process to fabricate them using LTCC and thick film technology.
Conventional pressure sensors are based on alumina, and this is the module. This is the sensor with screen-printed electrical contacts and sensing elements. So in the frame of the project, such sensor was realized in LTCC technology. This is, for example, this is the first testing sensor, and this is the final miniature pressure sensor, again realized in LTCC technology. Within this project, we could reach the very challenging goal of producing miniaturized pressure sensors in a manufacturing process that enabled a lower consumption of energy, required much less materials than the conventional ceramic pressure sensors, and we hope that the collaboration with both technological and industrial partner KEKO Equipment will continue.
The outcome of this project was a pressure sensor demonstrator allowing temperatures of up to 250 degrees, a temperature at which silicon pressure sensor already stopped working. As the demand for high temperature sensor grows, a working solution for measuring pressure is now available.
Breakthrough opens a new market and a new opportunity for the ceramic pressure sensors with a wide working temperature range